Have you ever stopped to think about the invisible network that powers, well, literally everything around us? I mean, it's hidden in our walls, buried under our streets, and tucked inside every single gadget we own. Yet, we almost never give it a second thought. I'm talking, of course, about wires and cables. No, really, just take a look around you right now. The lights in your room, the screen you're watching this on, that hum from the fridge in the other room, it's all running on a constant, invisible river of electricity. But how does that power get all the way from a massive power plant to the palm of your hand? Well, it all boils down to two fundamental things: wires and cables. But here's the catch that most people miss. They are not the same thing. People use the words interchangeably all the time, but in the world of engineering and electricity, they're completely different. And you know what? Understanding that difference is the key to seeing how our entire world is wired together. Okay, so let's jump right in and settle this once and for all. What is the real difference between a wire and a cable? It's actually way simpler than you might think. A wire is just one single strand of a conductor, a piece of metal like copper or aluminum, that's usually wrapped in some kind of plastic insulation. A cable, on the other hand, is basically a team of two or more of those insulated wires all bundled up together inside one big, tough outer jacket. So if you remember one thing, remember this: the wire is the basic building block, and the cable is the finished structure made from those blocks. So it makes sense to start with that building block, right? Before we can get into the crazy world of cables, we've got to get to know the humble, hardworking electrical wire. Every single wire has two essential parts. First, you've got the conductor. That's the metal core that carries the electricity. It's doing all the heavy lifting. And then, wrapped around it is the insulation. That's usually some kind of plastic, and its job is to keep the electricity where it's supposed to be, and more importantly, to keep us from getting a nasty shock. Now, not all wires are created equal. They generally come in three main flavors. You've got your solid wire, just a single stiff piece of metal. It's fantastic for permanent stuff, like the wiring inside the walls of your house where it's never going to move. Then there's semi-flexible wire, which gives you a little more bend when you need it. And finally, the most common one you'll see is flexible stranded wire. This is made of tons of tiny, thin strands of metal all twisted together. That's what makes it super flexible, and it's why we use it for things like power cords on our devices. All right, we've got wires down. Now, let's level up and see how these basic building blocks get assembled into the much more complex and powerful world of electrical cables. Now, this is where it gets really interesting because cables are built for specific jobs. They're classified in a whole bunch of different ways. I'm talking about how much voltage they can handle, what kind of metal they're made of, the type of insulation they use, even whether they have special shielding to block electrical noise or, get this, actual metal armor for physical protection. It's all about designing the perfect cable for the mission. And let's just zoom in on one of those classifications: voltage. The range is just staggering. A low voltage, or LV cable, is what you'd find in your home. But at the other end of the spectrum, you've got extra high voltage, EHV cables, carrying 400,000 volts or even more. These are the absolute superhighways of the electrical grid, and as you can imagine, the engineering that goes into them is on another level. And it's not just about raw power either. Take data cables. They're designed to protect really fragile signals. A telecommunication cable, for example, has pairs of wires that are twisted together. It's a really clever trick to cancel out interference from the outside world. Meanwhile, a coaxial cable, like the one for your cable TV, uses a metal shield wrapped around the central wire to make sure you get a perfectly clean signal. The form perfectly follows the function. Okay, enough theory, let's make this real. How does this whole right tool for the job idea actually play out in the real world? Let's look at a few examples I guarantee you'll recognize. First up, a data center. Just picture it. Endless rows of servers, all packed in tight, running 24/7 and generating a ton of heat. What kind of cables do you think you'd need in a place like that? Well, you can't just use any old cable from the hardware store, that's for sure. You need something highly specialized. They use what are called low-smoke, zero-halogen cables. Now, why does that matter? Well, in the event of a fire, normal cables release a thick, toxic black smoke. These special cables don't. And in a room full of million-dollar equipment and people, that is absolutely critical for safety. Okay, next scenario. Let's go from a climate-controlled data center to the top of a roof. What about a solar panel system that's going to be sitting out there for 25 years, getting blasted by sunlight, rain, ice, and wind? Yep, a standard cable would basically disintegrate after just a few years of that kind of abuse. That's why they make dedicated PV solar cables. Their outer jacket is a special compound engineered to withstand decades of harsh UV radiation and extreme temperatures without cracking. It's all about long-term survival.
And for our last one, let's bring it right into your home. Think about your air conditioner. It's a real power-hungry appliance. What makes the cable for an AC unit so much beefier than, say, the flimsy little cord for your bedside lamp?
It all comes down to thickness. An air conditioner draws a massive amount of electrical current, and all that current moving through a wire creates heat. To handle that load safely, it needs much thicker wires inside the cable. If you used a wire that was too thin, well, that's how fires start. It's a huge safety issue. So, after all that, what are the big things to remember? Let's try to distill everything we've talked about into a simple, practical framework. Honestly, it just comes down to asking 4 simple questions. 1. What is this cable's actual job? Is it for power, for data, something else? 2. What are its power needs? How much juice is it going to be carrying? 3. Where is it going to live? Is it going to be indoors, outdoors, buried underground? And 4, probably the most important of all, is it certified to meet modern safety and performance standards? Don't ever skip that one. Because ultimately, this is the main point. Choosing the right cable isn't some minor technical detail you can overlook. It is absolutely fundamental. It's about making sure a system is safe, that it's going to be reliable for years to come, and that it runs efficiently without wasting power or creating a hazard. So the next time you plug something in or you see a thick black cable running up a utility pole, you'll know. You'll know there's a whole world of engineering and purpose packed inside. Now that you know the difference, what hidden networks are you going to start to notice powering your world every single day?